Here's problem number 37 from section 3.6. It's asking that given f is a function of u, 2u over u squared plus 1, and u being a function of x, x squared, or 10x squared plus x plus 1, what is the derivative of the composite function f of g when x is 0? I'm going to do this two different ways. One would be to find the composite function and then find its derivative, in which case f of g ends up being 2 times the quantity, 10x squared plus x plus 1, all over 10x squared plus x plus 1, quantity squared plus 1. And if that's the case, then f of g prime, the derivative of f of g, ends up being, let's say using the quotient rule, ends up being 10 squared plus x plus 1 squared plus 1, there's my top, times the derivative of the bottom, so we got this whole thing, times the derivative of the there's the bottom, multiplied by the derivative of the top, which is 2 times the quantity 20x plus 1, minus the top, times the derivative of the bottom. So we bring the 2 down, keep the inside the same, reduce by 1, and then multiply by the derivative of the inside. And then divide that whole thing by the bottom squared. And now, when we ask the question, what is f of g prime when x equals 0, what we're going to do is we're going to replace x with all those zeros, and we're going to end up with 1 squared plus 1 times 2 times another 1 minus 2 times another 1 times 2 times another 1 multiplied by another 1, and then this is all over 1 squared plus 1 quantity squared. And if we do some calculations here, I'm going to end up getting that's 2 times 2 minus 2 times 2 all over 4, which equals 0. So there's one way to do it, but we see that that gets awfully complicated awfully quickly. So let me offer up an alternative to this idea, and that is, in this space, we're going to look at f of g prime as being the derivative of f with respect to u multiplied by the derivative of u with respect to x. In that case, the derivative of f with respect to u is going to be quotient rule, bottom times the derivative of the top minus the top times the derivative of the bottom, and then this is all over the bottom squared. Du dx is the quantity 20x plus 1. What is the value of this composite function's derivative when x is equal to 0? Well, it's pretty obvious over here that this is going to come into, just become a big value 1. But what about that one? What is going to go on there? Well, we can find out by saying, when x is 1, u is g of 1. Sorry, when x is 0, u is g of 0, and that's equal to 1. So I end up for this other piece saying, well, every place where I'm looking at the second, I replace every occurrence of a u with a 1. So I end up with 2 times 2 minus 2 times 2 all over 1 plus 1 squared. And if we evaluate that, we get the 0 in the numerator again. And you might see that this second way looks a tad bit easier.